Welcome to this course on elements of architecture. Architecture is more than just the art of designing buildings, it is the process of shaping spaces that respond to human needs, cultural identity, environmental conditions, and technological possibilities. This course introduces you to the foundational elements of architecture, focusing on dimensional awareness, graphic communication, freehand drawing, form, light and shadow, orthographic and perspective drawings, as well as applications such as curves and elementary design. Finally, we will look at the role of computer-aided design and drawing, often referred to as CADD. The course is divided into two modules. Module 1, Fundamentals of Architectural Representation and Communication. Module 2, Applications of Form, Design, and Technology in Architecture. By the end of this course, you will have a solid foundation in architectural graphics, visual communication, and design thinking, skills that will guide your professional journey as architects, planners, or designers. Let us begin with Module 1. Module 1, Fundamentals of Architectural Representation and Communication. 1.1 Dimensional Awareness. Architecture operates in three dimensions: length, width, and height. Dimensional awareness is the ability to understand and visualize how these dimensions interact to form space. For example, a room can be described by its floor dimensions, say 4 meters by 5 meters, but when we add height, the perception of the room changes entirely. A high ceiling creates spaciousness, while a low ceiling creates intimacy. Developing dimensional awareness allows architects to think in terms of volume rather than flat surfaces. It is the foundation of spatial design. 1.2 Graphic communication. Graphic communication is the primary language of architecture. Unlike spoken language, architects communicate their ideas through drawings, diagrams, and visual symbols. There are different forms of graphic communication in architecture. Sketches, quick drawings to capture ideas. Technical drawings, precise and scaled representations of buildings. Diagrams, abstract visuals explaining concepts, functions, or circulation. Clear graphic communication ensures the ideas can move smoothly from the designer's mind to the client, and eventually to builders and contractors on site. 1.3 Relation to environments. Architecture cannot exist in isolation, it must respond to its environment. This includes natural conditions such as sunlight, wind, rainfall, and terrain, as well as cultural and social contexts. For example, traditional desert houses are often designed with thick walls and small windows to reduce heat gain, while tropical architecture favors open spaces and ventilation. By relating architecture to its environment, designers create buildings that are sustainable, comfortable, and meaningful. 1.4 Freehand drawing. Before computers, freehand drawing was the primary method of representing architectural ideas. Even today, it remains essential for quickly expressing concepts. Freehand drawing develops observation, proportion, and coordination. Students are encouraged to sketch from life, objects, spaces, and even people. The purpose is not to create perfect art, but to learn how to capture ideas and forms accurately. Architects often use sketchbooks as thinking tools, where they refine their creative process. 1.5 Form in terms of light and shadow. Form is the shape and configuration of an object. In architecture, understanding form means analyzing how light interacts with surfaces. For instance, a cube appears differently when illuminated from above versus when light comes from the side. Shadows define depth, texture, and spatial quality. By studying light and shadow, architects learn how to emphasize or soften elements of design. This principle is especially important in rendering, visualization, and physical modeling. 1.6 Orthographic representation. Orthographic drawings are projections of a three-dimensional object onto two-dimensional surfaces. They represent exact measurements and are fundamental in technical drawing. Types of orthographic drawings include plans, horizontal sections of buildings, showing layout. Elevations, vertical projections, showing external faces. Sections, cut-throughs, showing internal structure. Orthographic drawings help architects communicate construction details to engineers, contractors, and craftsmen. 1.7 Diametric and perspective projections. In addition to orthographic drawings, architects use other projection systems. Diametric projection is a type of axonometric drawing where dimensions are represented at different scales along the axis. It provides a three-dimensional appearance without distortion. Perspective projection mimics how the human eye perceives space. Lines converge at vanishing points, creating realistic depth. Perspectives can be 1 point, 2 point, or 3 point. These methods allow architects to illustrate both technical accuracy and visual realism.